Have you ever just looked out a window and really wondered, why does it look like that out there? Why are there hills in one spot, but then it's totally flat somewhere else? Well, in this explainer, we're going to peel back the literal surface of our planet, and we're going to get into the deep, powerful forces that create everything you see, from the tallest mountains to the flattest plains. So you ready? Let's get into it.
All right, just take a look at these two pictures. On the left, you've got these incredible, jagged mountains just shooting up into the sky. And then on the right, a totally flat prairie that just seems to go on forever. The wild part is, these can exist in the same country, on the same planet. So what gives? How does one world end up with landscapes that are so incredibly different?
And that, right there, is the big question we're going to tackle. It's a huge puzzle, and the pieces are scattered everywhere, from the molten core of the Earth all the way up to the very air we breathe and even the plants growing at our feet.
So to put this puzzle together, we're going to take a little journey, 5 steps. First, we'll look at the Earth's restless surface. Then we'll check out the forces that build things up and the opposite forces that tear them back down. After that, we'll see how all that sculpting actually creates our climate. And finally, we'll see how that climate leads to the living landscapes we all know.
All right, first up, Earth's restless surface. It really all starts deep within the planet. To figure out what's happening on the surface, you've got to understand what's going on way, way down below.
So here's the key theme to wrap your head around. The ground beneath your feet, it's not one solid piece. Not at all. It's actually a giant puzzle made of these massive plates, and they're floating on molten rock. Imagine crackers floating on a thick, hot soup. That soup is the Earth's mantle, and it's constantly churning in these super slow-motion currents, just carrying the plates along for the ride. Okay, so if these massive plates are always moving, what do you think happens when they bump into each other? Well, they build stuff. Big stuff. In fact, you can think of these plates as the planet's giant construction crew, and their specialty? Building mountains.
And really, it all boils down to 3 basic moves. Plates can pull apart, that's called divergent. They can slide right past each other, which is transform. Or, and this is the one we really care about for mountain building, they can smash right into each other. That's a convergent boundary.
So when 2 of these continent-sized plates collide, all that incredible force and pressure has to go somewhere, right? And that somewhere is up. The rock buckles, it folds, it breaks, and it gets shoved towards the sky. And that's how you get what we call geologically young mountains, tall, sharp, and jagged, just like the ones you see here in the Western Cordillera.
But, for every force that builds up, there's another force trying to tear it all down. What goes up must come down, right? So now we flip the coin and look at the forces of destruction, the slow, steady, and unstoppable power of erosion.
Yeah, you can basically think of erosion as nature's demolition crew. And there are 3 main tools in the toolbox. First, you've got running water. Everything from a tiny creek to a massive river, just carving away at rock day after day for millions of years. Then you have glacial ice. These are like continent-sized bulldozers, just grinding and scraping away everything in their path. And finally, there's wind. It seems gentle, but give it a few million years, and it's like a constant sandblasting that just wears everything down.
So you've got this constant battle, right? Tectonics pushing up, erosion grinding down. And this battle is what gives mountains their age. A young mountain is still winning the fight against erosion, so it's tall and jagged. But you let that battle rage on for a few 100 million years, and erosion starts to win. You end up with old mountains, worn down, smoothed out, much more low and rolling.
And here is a perfect example of what that looks like. This is the Appalachian region. These guys are ancient, hundreds of millions of years older than those sharp peaks we saw out west. Believe it or not, they were probably once just as tall and spiky. But all that time, all that water and wind and ice, it's just slowly carved and smoothed them into the beautiful, rolling hills we see today.
Okay, so we've got the geology down. We understand how the land gets its shape, built up by plates and worn down by erosion. But that's just the start of the story. How does the shape of the land itself actually affect our weather? Well, that brings us to the climate recipe.
But first, let's get one thing straight, because it's super important. The difference between weather and climate. Weather is your mood today. It's sunny, it's raining, it's whatever. Climate is your personality. It's the long-term pattern. We're talking about personality here, the big picture.
So what are the ingredients that make up a region's climate personality? Turns out there are 6 main ones, and luckily, there's a super easy way to remember them. The acronym LOERN. Let's just quickly run through what each of those letters stands for.
First up, L is for latitude.
Super simple. The farther you get from the equator, the colder it gets. Done.
Next, O is for ocean currents. These are like massive conveyor belts in the ocean, moving warm and cold water around and affecting the air temperature near the coasts.
W is for wind and air masses. These basically act like delivery trucks, carrying weather conditions, like warm air from the south or moisture from the ocean, all across the country. E is for elevation. Again, pretty straightforward. The higher up you go in the mountains, the colder it gets, every time.
R stands for relief. That's just a fancy word for the shape of the land. And big mountains are like giant roadblocks for weather. They force air up, making it cool down and drop all its moisture as rain or snow.
And finally, N is for near water. Big bodies of water, like oceans or the Great Lakes, heat up and cool down way slower than land does. This has a moderating effect, making coastal areas have milder climates. Not too hot, not too cold. Okay, now let's put it all together. This is where you can really see it in action. Look at Moncton. It's in the low Appalachian hills, it's near a massive body of water, the Atlantic, and what do you get? A pretty mild temperature and a ton of rain and snow. Now jump way up to Resolute. It's super far north, that's latitude, and it's on flat, frozen lowlands. The result? The average temperature is a brutal -16, and it's practically a desert in terms of precipitation. See? Same planet, but the landforms and all those LORN factors create two totally different worlds.
And this brings us to the final piece of our puzzle. We've connected the deep Earth to the shape of the land and the shape of the land to the climate. So what's left? Well, it's how that climate determines what can actually grow there. We're talking about the living landscape.
See, a region's climate is basically the #1 factor in what kind of vegetation you'll find. When it comes to trees, you can pretty much split them into two big teams. You've got your deciduous trees, the ones with big, flat leaves that they drop every fall, and then you have the coniferous trees, think pine trees, with needles and cones that are tough enough to stay green all year round. So, take a guess. Where would you expect to find those tough coniferous trees? Exactly, in places with long, cold winters and not so great soil. These are the survivors, and they absolutely dominate the huge boreal forest, a massive ecosystem that is perfectly adapted for that tough northern climate. But what about somewhere like the interior plains? Remember how we talked about mountains blocking the rain? Well, this area is in that rain shadow. It's just too dry for a big forest to take hold. So what does the climate support instead? Grass, miles and miles of vast grasslands. And then, if you go to the absolute extreme, the far, far north, the climate is too harsh for even grass to thrive. The ground itself is permanently frozen solid just below the surface. It's called permafrost. And in a place like that, the only things that can survive are the absolute toughest of the tough, tundra vegetation like mosses, lichens, and little ground-hugging shrubs. So you see the chain reaction? The landform creates the climate, and the climate dictates what can live there. It's all connected. So there you have it. From the incredible violence of tectonic plates smashing together, all the way down to the type of moss that can survive in the Arctic, it's all one single connected story. You have these immense natural forces constantly building up and tearing down, sculpting our world for billions of years. And that just leaves us with one final big question to think about. We humans have become a geological force in our own right. So what new landscapes will our forces create?